Have you ever really stopped to think about the ground you're standing on? I mean, it's not just dirt and dust, right? It's like a library, and it's holding billions of years of history. In this explainer, we're going to go on a journey deep into that history and uncover the epic story written in the rocks right beneath our feet. So, what is that story really? Well, it's a tale of fire and pressure and water and just immense stretches of time. It's the story of how our planet is constantly recycling and rebuilding itself. Okay, let's dive right in. First things first, let's meet our main character, the rock. Put simply, a rock is just a solid mass where one or more minerals are all bound together. You can think of them as the fundamental building blocks of our planet. They're basically the pages on which Earth's autobiography is written. Our story kicks off in the most dramatic way possible, with fire. Igneous rocks are the originals, you could say. They're the primary rocks from which all other rocks are eventually formed. Their origin is actually pretty simple, but also incredibly powerful. They're born when molten rock, that's magma from deep within the earth, or lava that's erupted onto the surface, cools down and becomes solid. That's it. Now here's the really cool part. For igneous rocks, the speed at which they cool changes everything. When magma cools slowly, way down deep underground, it has time to form these large, beautiful mineral crystals. We call those intrusive rocks. But when lava cools super fast on the surface, say after a volcanic eruption, you get what we call extrusive rocks, with tiny, smooth grains. And you've seen these rocks everywhere, I guarantee it. That granite in your kitchen countertop? Yep, that's an intrusive igneous rock that took maybe thousands of years to cool deep inside the earth. And the dark basalt that forms entire volcanic islands? That's extrusive. It cooled in like an instant. All right, let's move on to the next chapter in the story. After the fire comes the breakdown. This is where sedimentary rocks come in. They are the great storytellers, the historians of our planet. And this quote just perfectly captures why they're so important. See, unlike igneous rocks, which are all about how they were formed, sedimentary rocks are all about history. They trap evidence of past life, like fossils, and they preserve all these amazing clues about ancient environments, winds, and even water flows. So how do you make one? Well, it's a three-step process called lithification. First, older rocks get broken down by wind and water into tiny pieces, which we call sediments. Then those sediments get carried away and settle down in layers, usually at the bottom of a lake or an ocean. And finally, the incredible weight of all the layers above squishes them together, and dissolved minerals act like glue, cementing them into a brand new rock. And get this, 75%. Think about that for a second. While other rock types make up the bulk of our planet's mass deep, deep down, it's the sedimentary rocks that form the world we actually see. They cover a massive 75% of the Earth's surface. They are, quite literally, the skin of our planet, and they hold all the stories. And what makes them so special are these three characteristics. First, they're stratified, which means you can actually see the distinct layers of history, like pages in a book. They're also fossiliferous, which is just a fancy way of saying they hold the precious remains of ancient life. And they're often porous, which is so important because that porosity is where we find resources like groundwater and petroleum. Okay, on to the final character in our rocky story, the master of transformation. Metamorphic rocks are what you get when you take any existing rock, igneous, sedimentary, even another metamorphic one, and you put it under intense pressure and heat. The name says it all, right? Metamorphic just means change of form. Think of it like baking. You take flour, eggs, and sugar, and with a little heat, you transform them into something completely new, a cake. The original ingredients are still in there, but they've been fundamentally changed into a whole new substance. That's metamorphism. And one of the telltale signs that a rock has been transformed like this is something called foliation. All that immense pressure literally squishes and realigns the mineral grains into parallel layers or bands. It gives the rock this really distinct striped or sheet-like look. And again, these are rocks we see all the time. The slate that's used for roofing tiles, that used to be simple shale. The beautiful marble we use for statues and buildings, that was once limestone. They're all incredible examples of old rocks being given a dramatic new identity. So we've got our three characters, the fiery igneous, the historical sedimentary, and the transformed metamorphic. But how do they all connect? This, my friends, is where the story comes full circle. You see, they're not separate things at all. They're all part of the same family, constantly changing from one form to another in this endless, planet-sized recycling program. And this diagram just illustrates the whole process perfectly. Let's just trace one possible path. So an igneous rock on the surface gets weathered down into sediment. That sediment then forms a sedimentary rock. That sedimentary rock could then get buried super deep, where it's transformed by heat and pressure into a metamorphic rock. And if that rock gets pushed even deeper, it can melt back into magma, only to one day erupt and form a new igneous rock, starting the whole cycle over again. The key takeaway here is that any rock can become any other rock. It's just a never-ending cycle of creation and recreation. Now, this isn't just some cool geology story. It has a direct, massive impact on our lives. This whole cycle is responsible for concentrating the minerals and resources that, well, fuel our entire civilization. Just take a look at this. The way magma cools in igneous formations, that gives us precious metals like gold and platinum, and even diamonds. And the layering process of sedimentary rocks, that gives us our fossil fuels like coal and petroleum. Each part of the cycle creates different kinds of value for us. And the impact goes way beyond just resources. The very same forces of erosion and deposition that create sedimentary rocks are also responsible for carving the incredible landscapes we see all around us. Here is a perfect example. You have a river that's meandering, right? It's eroding one bank and depositing sediment on the other. Over a long, long time, it can cut a new, straighter path for itself, leaving behind this curved, U-shaped lake. That's an oxbow lake. This is the rock cycle in action, visibly sculpting our world. So, the main thing to take away from all this is that the Earth's Great Rock Recycling Program isn't just ancient history. It's happening right now, slowly but powerfully all around us. And that leaves us with a final thought to chew on. If these forces are constantly reshaping our planet, what new mountains, what new valleys, what new coastlines are being forged today that will only be seen a million years from now?